We tend to view the seahorse as a delicate ocean novelty, an elegant, mythical creature drifting with the tide. The reality is much slower. Moving at just 5 feet per hour, the dwarf seahorse is the slowest fish on the planet. This pace is the result of missing standard fish biology. They lack a tail fin for forward thrust, have no ribs, and swim in an upright posture that creates massive drag. They also lack a stomach. Because food passes through their simple digestive tracts almost instantly, they have to feed nearly constantly to avoid starvation. This creates a paradox. A fish that cannot swim, has no armor, and faces constant starvation must somehow survive in a sea of predators. The seahorse shares a direct ancestor with the pipefish, a horizontal, fast-moving hunter. Roughly 25 million years ago, tectonic activity created new shallow coastal zones. In these waters, seagrass beds expanded into massive underwater forests. The seahorse adapted to this specific geometry. By tilting its body vertically, it evolved to mimic the upright blades of seagrass rather than outswim the fish around it. Evolution traded the ability to flee for the ability to become part of the background. Without speed, the seahorse relies on stability. It uses a square-ringed, prehensile tail to anchor itself to vegetation, staying stationary even in heavy currents. From this fixed position, it scans for food using eyes that move independently. One eye watches for predators, while the other locks onto a target. This wireframe diagram shows pivot feeding. The snout cuts through water with no detectable wake, approaching prey undetected. Once in range, neck tendons release stored elastic energy. The snout snaps upward, sucking in the prey instantly. Their world record slowness is a requirement for this style of hunting. Their entire biology is a specialized platform for stealth. The survival of the species relies on volume. Because seahorses are too slow to protect their young, less than 0.5% of newborns survive to adulthood. To counter this, they maximize their reproductive windows. Pairs perform a daily courtship dance to synchronize their biological cycles, ensuring they are ready to mate as soon as eggs are mature. During mating, the female transfers her eggs into a specialized brood pouch on the male's abdomen. This diagram shows how the father incubates the young. He provides lipids for energy and calcium for skeletons, while slowly shifting the pouch's salinity, the concentration of dissolved salt, to prepare the fry for the open ocean. Offloading gestation allows the female to immediately start producing the next batch of eggs. This significantly reduces the time between clutches. After 2 to 4 weeks, the male undergoes intense contractions. He can birth up to 2,500 fully formed independent seahorses in a single brood. Male pregnancy is a biological solution to high mortality, allowing the population to outproduce its predators. This specialization leaves them vulnerable to rapid environmental change. They rely on the complex structures of coral reefs and mangroves to hide and hunt. When humans use bottom trolling nets to harvest fish, the seahorse's instinct to anchor becomes fatal. They cling to the vegetation as it is scraped off the seabed. The result is a bycatch problem on a massive scale. An estimated 37 million seahorses are accidentally removed from the ocean every year. A creature adapted to sit perfectly still has no defense against industrial gear moving through its habitat. There is also a direct, targeted market. Millions more are harvested annually for the traditional medicine and souvenir trades. Populations struggle to recover from this harvesting. Seahorses are monogamous and sparsely populated, meaning if a mate is taken, the survivor may never find a new partner. The high demand drives the value of dried seahorses to as much as $3,000 per kilogram. By weight, they can be as valuable as silver or gold. The seahorse is a specialist in a world that is becoming increasingly hostile to specialists. They are refined for a stable, ancient ocean, but they are physically unequipped for the human era.